All right, you guys, example 6 flows very similarly to example 5. So if you feel confident about example 5, I highly encourage you to try example 6 on your own. Otherwise, just follow along and you'll have so much fun right with me. All right, let's get going. So again, we have tangents and secants intersecting outside of the circle in this case. Okay, which quickly I'll recap the rule, which that is definitely not our rule. This is our rule right here. Okay, so basically, if we square the length of the tangent piece, it will equal the piece of the secant that's on the outside of the circle times the piece of the secant that is outside the circle plus the piece of the secant that is inside the circle. So we'll be using that nifty property to help us solve. All right, let's get this show on the road. So I'm going to start with my tangent piece. So what segment represents, oh, actually, hold on. Before we do that, let me label my tangent and my secant lines. Might as well, right? So my tangent segment is d to the g. And which segment is my secant? Nifty, you guys, it is d to the f. So my secant is df. Okay, now let's get the show on the road. So I'm going to start with my tangent piece, which is dg, and we're going to be squaring that bad boy. Okay, and that will equal the piece of the secant, or the segment of the secant, that's kind of hard to say, that's located outside the circle, which what piece of the secant is outside the circle? Yes, correctamundo, it is d to the e. So it'll be d times de, so the piece on the outside of the circle, plus the piece of the secant that's on the inside of the circle, which is e to the f. All right, you guys, let's start filling in those values. Bam, 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 bam. Okay, so d to the g is 10 squared equals de, which is 7, times de, which is 7, plus ef, which is y. All right, let's get going. 10 squared will give me 100. All right, and then what do you do with the value that's outside of a parenthesis? Yes, my wonderful, smart, brilliant students, you do distribute that thing. So 7 times 7 is 49, plus 7 times y, which is 7y. All right, let's solve this thing for y. So I'm going to bring 49 to the other side, which the way I do that is by subtracting 49 on both sides. Okay, which 49 minus 49 cancels and turns to 0. And 100 minus 49 is 51. Okay, and you know, Miss Long, I like my y to go first. So I'm going to write my 7y first and then the 51, because that's really irking me right now and it's bothering me. So we have 7y equals 51. All right, lastly, we need to move 7 to the other side, which 7 is secretly multiplying to the y, which means we'll divide both sides by 7. 7 divided by 7 cancels and turns to 1. Whoa, that was a vicious cancel. Ah, watch out for that. All right, so that will be y equals 51 over 7, which 7 does not divide evenly into 51. The closest thing, 7 times 7 is 49, and 7 times 8 is 56. So I'm just going to leave that as 51 sevenths. And guess what, you guys? We're done with that one. So I think that one deserves a cat too. What do you guys think? Totally, I know. All right, well, that's how we use the tangent secant rule. So yay. All right, guys, that was all of our different segment properties that intersect inside and outside of a circle. So, yeah, there you go. Nice job.